So back to our vibrating cantilever, which is being driven with a sinusoidal signal at approximately the first natural frequency of 17.4 hertz. And we can see the laser beam tracing very slowly up and down there, and when it gets towards the top of the beam we can clearly see the amplitude of the vibration. The video sample rate will mean that that's a little bit digitized relative to what you can see with the naked eye when you stood alongside it. If we look at the oscilloscope, we're making a measurement immediately of the vibration of the beam as is expected. The blue trace being a time signal that the vibrometer output gives us, and we can see it steadily increasing as we start from the root of the beam up towards the tip of the beam. You can also see some signal level dropouts in this signal here as a result of the speckle noise that was mentioned in a previous video. If we look at the fast Fourier transform of that signal, then we can immediately see the single peak here at 17.4 hertz as expected from that vibrating beam. If we now increase the frequency of the scanning and have another look back up at the beam, we can see that I'll slowly increase the scan frequency. We can now start to see some quite interesting patterns of the laser beam as it tracks up and down the beam. And as we increase, for example, to double the driving frequency, so 34.8 hertz, then we'll be doing exactly 2 passes of the laser beam up and down the vibrating beam for each one of the beam vibrations, each period of beam vibration. And I can shuffle that slightly forwards by 0.1 hertz, and we can see the laser beam now beats out of frequency slightly as the beam vibrates, so it's advancing slightly by, it takes 10 seconds to do one full pass through there. If we look at the measurement that we make on the oscilloscope, we can see now that the measurement that we're making is modulated by the position of the laser beam on the vibrating beam, and in the frequency domain we get sidebands either side of the fundamental frequency as a result of the fact that the beam is moving backwards and forwards, and the mode shape is captured, or the operational deflection shape is captured by the amplitudes of these various peaks.